Welcome back, everyone. Today we're diving into a critical and, frankly, potentially life-saving explainer. We are going to examine the very real and often completely invisible mechanics of industrial disasters. We aren't just looking at what went wrong. We're doing a deep, forensic dive into exactly why safety systems fail, using actual case files that tragically cost workers their lives. Our goal today is pretty clear. We want to equip you with the direct understanding necessary to recognize these fatal hazards way before they ever strike.
To do this properly, we're using the Investigator's I framework. The forensic data and analysis we're unpacking today have been meticulously prepared by consultant Tamer Abdullah Sharaki. Now, he's a highly respected safety consultant and accident investigation expert, a certified safety manager, and an active member of the NFPA, IAM, and I'm Arrest. So we are definitely leaning on his absolute authority today to decode these complex industrial tragedies.
Okay, here's our roadmap for today. We'll start with the Investigator's I framework, dissect the mechanical failures at NaturPak, and really unpack lockout/tagout. From there, we'll scale things up to the massive blast at Clairton, cover API regulatory solutions, and finally synthesize these critical lessons.
Part 1. The Investigator's I, where we uncover industrial negligence.
The core thesis of this explainer is actually quite simple. In high-risk, heavy industrial environments, survival isn't just about throwing on a hard hat. True safety demands two things happening at the exact same time. First, you need flawless execution of individual, micro-level procedures. And second, you need macro-level structural environments that are specifically engineered to protect human life. If either that micro or macro level fails, well, disaster is pretty much inevitable.
Let's move to Part 2. NaturPak. The fatal pressure, and the anatomy of a tragic, entirely preventable boiler explosion.
Get this timeline from the NaturPak facility in Wisconsin because it is truly shocking. On February 12th, a boiler blasts open. This results in a fatality, and another worker suffers a concussion and severe burns. Then, just weeks later, on March 18th, a second, fatal boiler blast occurs at the exact same facility. Naturally, this triggered a massive OSHA investigation. I mean, to have two separate deadly incidents happen in the exact same facility within a month of each other, that points directly to systemic, deeply rooted safety violations.
So what actually happened? Let's break down the precise mechanical chain of events that caused that first tragedy. It started with a technical design detail. A vent line meant to release steam simply becomes completely blocked. Because of this blockage, latent, invisible pressure starts building up inside the boiler. It's essentially a ticking time bomb, but outwardly, it looks perfectly fine. Eventually, unable to contain the pressure, the boiler cover suddenly blows open, causing a catastrophic, fatal release of high-temperature steam. Routine inspection of these vent lines isn't just checking a box on a clipboard. It is quite literally a matter of life or death.
$364,000. That represents the severe financial penalty handed down by OSHA following these dual tragedies. But that fine isn't just for the boiler explosion itself. It actually encompasses a horrifying array of gross negligence. The investigation revealed a severe lack of personal protective equipment, extreme hazards in permit-required confined spaces, and, unbelievably, a lack of emergency water access. Think about that for a second. When workers suffered severe thermal burns, they couldn't even access emergency washing stations to mitigate their injuries. Unacceptable.
Which brings us to Part 3, LODO and Zero Energy, the missing procedural defense. We really need to drill down on this definition. A zero-energy state is a condition where all hazardous energy sources, whether that's electrical, mechanical, or like in this case, pressurized steam, are isolated, controlled, and completely released. This is the ultimate, non-negotiable goal of lockout-tagout or LODO procedures. You never, ever open heavy machinery until a zero-energy state is completely verified.
The failure to verify that zero-energy state is exactly what caused the March 18th tragedy at NaturPak. Workers opened a boiler that was still retaining latent pressure. And the consequences were just devastating. A sudden cover blow-off, a violent emission of steam, boiling liquids, and volatile organics instantly filling the workspace. It resulted in immediate, horrific thermal burns. 2 workers died on the spot, and a third was hospitalized with severe injuries. This is exactly what happens when LODO protocols fail.
Part 4, Clairton and blast zone occupancy. We're scaling up from a single boiler to a massive, facility-wide explosion. We're looking at the U.S. Steel Clairton Coke Works facility in Pennsylvania, and the sheer scale of the devastation here is mind-boggling. On August 11, 2025, a massive explosion ripped through the area between coke oven batteries 13 and 14, a space they call the transfer area. The structural destruction was absolute. We're talking shattered concrete walls, twisted steel beams, and completely collapsed roofs.
What fueled a blast of this magnitude? Coke oven gas. It's a highly hazardous, volatile mixture of hydrogen, methane, and carbon monoxide. It leaked, fouled an ignition source, and detonated. But the true tragedy here is where the explosion actually happened. The blast completely destroyed 2 control rooms and collapsed the ceiling and walls of a break room. These were rooms meant for normal daily occupancy. 2 workers were killed, one of whom was buried under the rubble for 9 hours, and 5 others were seriously injured.
Part 5. Facility Siting and API, the regulatory solution. How on earth do we prevent occupied rooms from being built inside blast zones?
Following the Clairton disaster, the Chemical Safety Board pointed directly to systemic structural standards, specifically the American Petroleum Institute, or API, which provides the gold standard for protecting occupied structures in industrial environments. They have 3 crucial recommended practices: API RP 752 for permanent buildings, 753 for portable buildings like trailers, and 756 for tents. Simply put, if a facility processes explosive or toxic chemicals, these guidelines dictate exactly where humans can and cannot safely gather.
The evaluation process outlined by API and the Center for Chemical Process Safety is straightforward, but it's incredibly rigorous. First, you have to identify any building with intended or intermittent occupancy. That means even a sporadically used break room or a weather shelter has to be included. Next, you assess the worst-case consequences of a fire, explosion, or toxic release hitting that specific building. Finally, you mitigate those hazards, or you completely redesign the facility to move that building out of the danger zone entirely. You just do not put a break room next to a volatile gas line, period.
Part 6. Lessons in Industrial Safety. Let's synthesize all this and turn it into action.
This brings us right back to our opening thesis. NaturPak represents a fatal disaster born from procedural flaws, workers failing to verify a zero-energy state using lockout/out, which led to a deadly release of pressure. Clairton, on the other hand, represents a disaster born from structural flaws, management failing to properly execute facility siting, placing occupied break and control rooms directly in a high-risk blast zone. A plant is only truly safe when workers flawlessly execute their micro-level LODO protocols and management rigorously maintains macro-level structural facility siting. It takes both.
I want to leave you with a final provocative question. Think about your own workplace for a second. Are your facility's break rooms secretly sitting right in the middle of a blast zone? And out on the floor, is every single worker verifying a complete zero-energy state before they open a valve or a cover today? Industrial safety is never just an abstract concept. It's an active, daily discipline. Take these lessons, audit your environments, and make sure that what happened at NaturPak and Clairton never happens on your watch. Thanks for joining me on this explainer, and please, stay safe out there.